Hello, and welcome to our tutorial on creating an inbound calls interactive voice response, or more commonly, an IVR, using the Aheeva Cloud Contact Center Solution. Despite the proliferation of social channels as a communication media, the phone remains the preferred communication channel for a majority of customers. Today, we guide you, step by step, in creating an IVR that not only greets your callers warmly but also connects them to the right agents. So, let's get started. Creating a working IVR from scratch can seem like a tedious endeavor at first, but in this video, we will walk you through the different steps to show you how simple it is with the Aheeva Inbound solution. To have a working IVR service, you need to complete the following steps. First, make sure you have a SIP trunk set up. Then purchase a phone number to receive calls. Then create the skills. Create an inbound queue. Create an agent group and the agents. Create the sound files to be played in the IVR for prompts, hold music, and announcements. And finally, create the routing script, or the IVR. Actually, as a last step, make sure to make some calls to test the IVR and talk to an agent. As you can see, there are several tasks to complete prior to building the IVR, but rest assured, this video will guide you through them. In this video, we will skip the details on how to configure the SIP trunk and phone number. Now, with the telephony part out of the way, let us start building the pieces that are part of your contact center. All the work will be done from the Aheeva Manager, a web-based application that you can use for configurations and monitoring the operations. We start by connecting to the Aheeva Manager. The home page gives direct access to all the elements of your contact center. First, we start by creating the skill set that we will associate with the queue. Every skill is unique and is determined by its name and value. A skill can be a specialization like technical support or billing inquiries, or a language like English or Spanish. Skills ensure that incoming communications are directed to the most appropriate agent. In our scenario, we only need to create the skill for technical support. When creating a new skill, we can either assign it to agents right away, or do so from the agent setup page. Since we do not have any agents created yet, we will do it once we create them. Next, we create a queue. A queue is a line of incoming calls waiting to be answered by an available agent. When all agents are busy, incoming calls are placed in a queue, where they wait until an agent becomes available. While in the queue, callers often hear hold music or recorded messages. Let's create one. First, we must select its type. In our case, it is an inbound queue, and we click on Add. Let's name our queue Tech Support Queue and specify that it will be used for calls. The timeout is the maximum time that the call will wait to get connected with an agent before exiting the queue or abandoning. We will set it to 600 seconds or 5 minutes. The call priority parameter that you see is the initial priority of all calls entering this queue. By default, all calls that enter the queue will have the same priority because they will all be using this value. But what happens if we define another queue with the exact same skill set, but we set its call priority to 5? Well, in that case, calls in the first queue that has the priority 1 will get distributed after the calls in the second queue, because 5 is considered a higher priority than 1. When you have more than one agent qualified to handle the call, the tiebreaker tells the system which criteria to use to select an agent. The tiebreaker most idle means that the agent that has been waiting the longest will take the call. Least busy means that the agent that spent the least time on the phone so far today will take the call. And most skilled, as its name implies, selects the agent with the highest value of the skill. An alternative to skill-based routing of calls, you can use the agent selection criteria to tell the system to select an agent from a specific agent group, not by skill, or to target a specific agent. Later on in this video, once we have created the agent group, we will create a second queue that has the agent selection criteria set to agent group. It will allow us to distribute calls to agents regardless of the skills. When we start building the IVR, we will see why we need it. Since we prefer using skills, we must select the skill set that will be associated with the queue. This can be a single skill, or a combination of skills. When having multiple skills, The matching criteria tells the system whether agents must satisfy all of the skills conditions or any one of the conditions. In the condition section, we specify that this queue will distribute calls to agent having the technical support skill greater than 80, ensuring efficient and effective issue resolution. With this technical support queue, a caller with a technical query will be directed to the most idle agent available that has the skill technical support greater than 80. Let's save this queue. We are now ready to create an agent group. All agents must belong to some agent group, and an agent can be part of one and only one agent group at a time. This helps in organizing your agents based on departments or expertise. Navigate to the Agent Groups page. In addition to grouping agents, an agent group page is the place where you can specify settings, permissions, and configurations that will apply to agents in the group. These settings will be inherited by all the agents, but they can be overwritten for a specific agent from the agent's configuration page. The settings for an agent take precedence over the same settings for the agent group. As you can see, there are 4 main sections on the page. We start with the general settings. Let's name this agent group Global Group. You must assign a caller ID and a SIP trunk. They will be used when an agent from this group manually makes a call from the agent application. The caller ID and trunk can be different from the ones used by the automatic dialer for outbound campaigns. Next, you can specify the URL that will automatically open in the agent application when doing a manual dial, and the URL that opens right after the agent logs into the system. We will leave these fields empty since we have no need for them. As you know, the Aheeva Cloud Contact Center Solution is an omnichannel platform. In addition to calls, agent can handle different types of communications like chat, email, SMS, or social channels. While agents can only handle a single call at a time, the number of simultaneous text-based communications varies and depends on various factors like the complexity of the client's cases, the proficiency of the agents, or even nature of the channel. For example, a live chat on a website might require quicker responses than an email or social media message, thus influencing the number of simultaneous interactions. By default, we limit the number of simultaneous communications, excluding calls and chat, to 10. However, you can increase or decrease this limit, or even specify the number allowed per type of channel. Next, you have the option to set the wrap-up timeout for calls and chat. Agents automatically get in the wrap-up state when the call or chat ends, and they can continue filling out forms or other tasks. When the wrap-up timeout expires, the agent state will change to either not ready, which means the agent will no longer receive communications, or ready. The number of seconds you specify as maximum wrap-up for productivity is the time that the agent can stay in wrap-up mode without negatively affecting his productivity. Any excess will reduce the productivity ratio of the agent. The 2 parameters under agent threshold time are only used when the agents are set up to receive non-forced calls. Non-forced calls are calls that ring the agent phone instead of having the phone answer automatically. In such a setup, agents have the choice whether to answer the offered call or decline it, in which case, the call will go to the next agent. Now let's switch to the permissions section. The permission page has 2 parts. The first set of options specifies the type of phone an agent can use and how it connects to the Aheeva platform. If none of the options is checked, then agents can use the Aheeva WebRTC phone built into the agent application for audio calls only. The first checkbox means that agents can use a SIP phone, whether soft phone or hard phone. The second option means that agents can use the Aheeva WebRTC phone for video calls. And the third and last option means that agents will not use the built-in WebRTC phone, and instead either use a SIP phone registered internally, or any external phone reachable by the SIP trunk. On the second part of the page, you can specify what information and functionalities will be available on the agent's workspace. The next section is where you assign agents that are already created to this agent group. If you don't have any agents yet, this list will be empty. Keep in mind that you can also assign an agent to an agent group directly from the agent's configuration page. Now, let's go to the last section. It has two parts. Under soft phone, you can choose whether agents will be put in the ready state right after they log in, or they remain in the not ready state until they manually change state. You can also choose which call control buttons will be available for the agent, as well as the possibility to prefix phone numbers with a code when doing manual dials or transferring and conferencing a call. You also have access to different recording settings from where you can enable or disable agents' screen captures, enable or disable audio recordings for outgoing calls, and allow the agents to pause the recording and have it resume automatically. Finally, you can decide which not ready reasons that agents in this group can choose from. Agents use different not ready reasons for breaks, lunch, coaching, or any state other than the ready state. We already have a not ready reason called break that is global and is available to all agents. Make sure you save the agent group. Now that we have created the agent group, and as we had mentioned earlier, we want to create a queue that will distribute calls to the most idle agent in the agent group, and not by skill. You do not really need to have this second queue. Having it is optional, and we will explain why we want it once we start building our IVR. We will call it Global Queue. The agent selection criteria will be by agent group, and we select the group that we have just created. Now let's create an agent. We start with the name, Alex Johnson. The extension can be alphanumerical and is used to form the SIP username that the platform will use to reach the agent's SIP phone. Once the agent is created, you can see the SIP username that was generated from the extension value in the SIP section. Since we already created an agent group, you can select it here. The agent will inherit all the agent's permissions specified for this agent group, but you can still modify them individually if you wish. The inherited settings become accessible in the permissions section. Next, with the agent type, we decide whether this agent will only handle inbound calls, outbound calls, or both. To use multi-factor authentication, the agent must have his email verified. We will skip the details of setting up the MFA in this video. Next, we specify the username and password that the agent must use to log into the agent application. And finally, since we decided to use skill-based routing to distribute calls, we need to give this agent the needed skill. The skills section lists all the available skills. Let's give the skill tech support the highest value. The value range, which spans from 0 to 100, indicates the proficiency. A higher number represents a greater expertise. Let's save the agent. Having a professional and clear audio file for your IVR is crucial for an effective customer interaction. With Aheeva, it's simple and efficient. Navigate to the sound file section and click on Add Sound Files. Sound files are used for either IVR prompts or hold music. We will start with the audio files that will be used as prompts in the IVR. If you want your IVR to service callers in different languages, then you must create the audio files in each language while making sure to use the exact same file name across all languages. For example, you can see here that we have the audio for the main menu in English and Spanish, and we gave it the same name in both languages. We will talk about multi-language IVR some more when we start building our IVR. As you can see, we already have most of those audio files uploaded, but here is how to do it. Let's upload an audio file that plays the business hours in English. If you already have the audio file pre-recorded, simply click on Add. And make sure you have upload as the source, playback as the type, and English as the language. Then, click on the Upload button and choose the file from your computer. You must make sure your audio file is in a supported format like MP3 or WAV. We also need the same sound file in Spanish. Add, upload. Save. When you have an IVR in 2 or more languages that callers can choose from, you must create the same audio file in each language and give it the same name. Next, you need to create the hold music. We will upload a music file that will be played to callers waiting in the queue. Hold music can transform a customer's waiting experience. From the sound file section, click on Add Music on Hold. Give it a name and upload an MP3 or WAV music file. Now with the hold music ready, you may want to play announcements to callers waiting in the queue. An alternative to uploading pre-recorded files is using the AWS Poly integration to quickly generate audio files. Poly is an Amazon text-to-speech service that translates text into lifelike speech. You must first have an AWS account already configured to use it. Luckily, we already have one. We will use Poly to generate an audio file for announcements that invites callers to visit our website. You must set the source of the file to text-to-speech. This text-to-speech service offers different languages, dialects, and voices. Next, type the text to synthesize and give it a name. You can listen to the generated audio and, once satisfied with the result, save the file. First in English.
You can visit our website at the www.aheeva.com for more information on how the Aheeva Cloud Contact Center Solution can help your business thrive.
Then in Spanish, with the same name. We will set up the hold music and announcements while creating the IVR routing script. Sound files added using text-to-speech become part of the same pool of audio files as the ones we uploaded, without any distinction. They can be played back the exact same way in an IVR.
Puede visitar nuestro sitio web en www.aheeva.com para obtener más información sobre cómo la solución de centro de contacto en la nube de Aheeva puede ayudar a prosperar su negocio.
We finally made it to the part you've been waiting for, and that is the actual creation of the IVR. An IVR can make or break a customer's calling experience. Efficiently setting it up is vital. Let's delve in. We want to create a simple IVR that greets callers in English and Spanish, prompts for a language selection, verifies the business hours, offers a menu, queues the call with the options of leaving the queue without losing our position, plays music and announcements to callers while they are waiting, and finally connects the call to an agent. The routing script for your IVR is a set of rules and actions that determine how the calls are handled and distributed to agents. You can use the Aheeva scripting tool to customize your routing script without any programming skills. Let's navigate to the routing script page and start by adding a new routing script. The workspace is divided into several sections. The large space that you see is a canvas on which you place all the boxes. On the right side you have access to a multitude of icons to select the action you need. You can hover over any of them to see a tip note on what they are. On top of it you can see a field for the name of the routing script, a zoom handle, and a checkbox to flag this routing script as active or not. When adding a new routing script, or IVR, an initial if-then condition is created that you must use to associate this IVR with a phone number. The box tells the system to continue with the execution of this IVR for calls arriving at this number. Let's select one. Next, we need another box to answer the arriving call. The answer box is added automatically and connected to the first box. If you wish to disconnect two boxes, you must click on the label from which the link started and confirm the removal of the link. The links between boxes indicate the sequence of actions to execute. Let's reconnect the two boxes by creating the link again. You do this by first clicking on the true label of the first box, then clicking on the circle in the upper left corner of the second box. I always like to save the routing script at this stage before proceeding any further. I will name it Inbound 73 and save it. It is good practice to save frequently, not to lose any work and having to start all over. Remember, this is a web page, and you can accidentally hit the back on your browser and exit the page. Next, we want to welcome the callers with a warm greeting. Since our IVR is bilingual, and the caller didn't choose a language at this stage yet, we want to play the greeting in both languages. But before we explain how to do this, there are two things that are essential to know. First, you need to know that languages are like containers in which you store the sound files, and you can have two files with the same name in different languages. When you play a sound file that exists in several languages under the same name, the one in the container corresponding to the language set will be played. The second thing to know is that the English language is the default language. This means that if you do not explicitly select a language, then the English language will be chosen when playing a file. You only need to set it if you want to change to a language other than English, or if you want to go back to English after having switched language. So how can we play a bilingual greeting prior to selecting the language? This can be done in more than one way. One way of doing this is by having two greeting audio files, one in each language, and using the playback box twice, while changing language in between, and changing back to English after the last playback. Another way is by having a single greeting audio file in which the message had been recorded in both languages, and doing only one playback. In this case, there is no need to change language since English is the default container. And a third way is by having two greeting audio file in the English container, but one of them had been recorded in a language other than English. You can then use the playback box twice to play the greeting. In our IVR, we will use the second method to keep the flow simple. Now let's go back to building our IVR. To play the greeting, or any other sound file, you use the playback box. Create a new playback by clicking on its icon, and choose the greeting audio file. This is the English and Spanish greetings in a single file under the English language. Link the answer box to the greeting. Next, let's ask the caller to choose a language. For this, we will use the Get Input box. Get Input is used to offer a menu to callers and capture their selection. It captures a single key input, or a sequence of keys of fixed or variable length. It also monitors the number of invalid entries and timeouts. Configuring the Get Input is straightforward. First, you must specify the name of the variable that will store the input, and which sound file to play to the caller. Just like the greeting, this sound file is bilingual. Then you must consider how to handle errors and whether to replay the prompt when an error occurs. An error can be a timeout, where the caller takes too long to finish the data entry, or an invalid entry. We specify the error messages to play when there is a timeout, an invalid entry, and when the maximum number of allowed error has been reached, which is the on-last error message. Let's also put 5 seconds as the maximum time to wait for an answer before resulting in a timeout. A timeout is also counted as an error. To capture a sequence of keys, you must specify the minimum and maximum length of the sequence, and the ender key, which is the pound key by default. The ender key marks the end of the sequence entry. Any sequence shorter than the minimum length will result in an error, and when the maximum length is reached, the sequence entry stops automatically without the need for the ender key. In our case, the response to the language selection is a single key, so we must set the minimum and maximum length to 1. With a single key selection, we must select the valid entries. Our valid selections are 1 for English, or 2 for Spanish. The label will be displayed on the connector when we close this box. If the Get Input ends due to the maximum number of errors reached, the call flow continues either from the timeout exit or from the error exit depending on the last error. When Get Input exits with timeout or error, we will end the call with the Hang Up box. Next, we must set the language according to the caller's selection. We do this with the Set Language box by selecting one of the available languages. For one, we choose EN for English. And for 2, we choose ES for Spanish. Now let's verify the working hours. All routing scripts have a standard set of variables, or call properties, associated with them, and every new variable created in the IVR gets added to the set and becomes accessible by different action boxes inside that IVR. When you click on the information icon found on the right side, you can see the list of variables. For the business hours, we need to verify the variable call time. We will use the switch condition to verify the business hours. Make sure the call property call time is selected. Choose the operator less than and put 090000 as a parameter. This number indicates the hour 9, minutes 0, and seconds 0, or exactly 9 a.m. Add a second entry by clicking on the plus sign, and choose less or equal, and put 190000 as a parameter. This is 7 p.m. The conditions in the switch box are evaluated from the top down, and the first condition that is true will exit the box. This means that in certain situations, like what we just did, the order of conditions is important. As you can see, the switch box we just configured has 3 possible exits. If the call arrives before 9 a.m., then the call flow will exit from the branch less than 9 a.m. If it is within business hours, then it will follow the less or equal 7 p.m. branch. Finally, if it is after 7 p.m., it will follow the default branch. The default branch is for any condition not explicitly specified in the switch box. Next, let's use playback to inform callers that our offices are presently closed and hang up. We will connect the playback to the 2 exits of the switch box, and also add a hang-up box. If you wish, you can connect this playback box to the same hang-up box above, previously created. But sometimes, to avoid having connection lines crossing over each other, we create another hung-up box. Once the language is selected and the call is within the business hours, we can play the main menu. Using a Get Input, caller can choose between sales, checking the account balance, technical support, or repeating the menu. Just like we did in the Languages menu, we need to handle invalid entries and timeout errors. Valid selections are 1, 2, 3, and star to repeat the menu. The labels will add clarity to the IVR diagram. We want to keep this IVR simple so only technical support calls will get queued. For sales, we will play a brief message, then hang up. For the account balance, we will call a web service that will return the balance and play it back using AWS Poly text-to-speech before hanging up. The web service box allows you to connect to any third-party system that offers SOAP APIs. All you need is the URL that points to the WSDL file that defines the functionality of the web service. The first step is to enter the URL of the WSDL file and click the button Validate. This is important for 2 reasons. 1, it makes sure that the URL is reachable. And 2, it also pulls the list of all the operations available in the WSDL file with the list of parameters for each one. If the validation is successful, a notification will briefly appear at the bottom of the window, and the operation list dropdown will show the available operations retrieved from the WSDL file. When we select the operation, the parameters that we can parse to it appear. In our case, only the operation account details is available. When selected, we can see that it requires a parameter called account reference. Each parameter can either take a hard-coded value or a variable available in the current routing script. In this example, we will hard-code the value of the account reference for simplicity. In a production routing script, we should prompt the caller to enter the account number. Let's store the returned result in a variable account info. The timeout limits the time we wait for the URL validation to complete. The developer of the web service must inform what it will return as a result. It is usually an array structure, but the number of elements in the array depends on the format of the operation. Our web service returns a 2-dimensional array, lines and columns, that includes the type of the account and the balance. To access a particular element in this table, you must use the column number and the line number. Numbering starts at 0. The upper row and the leftmost column are numbered 0. We need the value of the balance found at the intersection of row number 1 and column number 1. We connect the web service to option 2. If the web service fails or times out, you can simply play a technical difficulties error message and hang up. Connect both exits to the playback. Now let's play to the caller the account balance using AWS Poly. But prior to using Poly, we must know the language to specify because Poly does not use the system language that we set earlier with set language. It needs to explicitly be told what language to use. In addition to creating sound files for playback, you can use Poly text-to-speech to dynamically build the text and play it to the caller. You can add variables to the text. A variable must be preceded by the $sign. It can be any standard variable available, or a variable that we just created with the web service call, like account info. We have to do this for each language. So we call Poly again, and we change the language to Spanish, as well as the dialect and voice. And here we have text-to-speech playing back the account balance in English or Spanish, depending on the language selection. Now let's continue with the third option of our main menu, the technical support option. The first thing we want to do is verify the number of calls in the queue. If it is too high, then we will play a message and ask the caller to call back at a later time. If not, we will queue the call. We use the statistics box to have access to real-time statistics on queues or agents. Let's get the number of waiting calls in the queue and store it in a variable. We connect the statistics box to option 3. The use of real-time statistics this way helps us better manage callers' expectations and avoid long waiting times. We need to test whether the number of calls waiting in the technical support queue is higher than a certain threshold we define, like 50. If the number of calls is higher than our threshold, we inform the caller, and we hang up. If not, we queue the call. Before queuing the call, let's talk a little bit about hold music. There are two different hold music that can be played to the caller. One is the music played when the call is in the queue, and another one is the music played when the caller is already talking to an agent, and the agent puts the call on hold. The two can be different. The hold music played in the queue is specified inside the pickup box, which is the box that queues the call, while the agent hold music is the default hold music of the system. We change the system default music with the set music on hold box. We will use it to choose our own music. It must be called before the pickup box. We choose the hold music we had uploaded because we want the caller to hear the same music while in the queue, and if an agent puts the call on hold. We will call set music on hold if the number of calls in the queue is less than 50, and right before we queue the call. It is time to put the call in the queue. We queue the call using the pickup box. Let's click on it and start configuring it. The first thing to do is choose the queue. You have a list of configured queues to choose from. Once you choose the queue, you will see the parameters for this queue in read-only mode. If you need to edit the queue, you can do it without having to leave the routing script builder by clicking on the little square next to the queue name. For skill-based distribution, the system looks at the queue, checks the required skill, say, technical support, and parks the call until an agent becomes ready. In the URL field, you can specify the address of any web-based form or CRM page you want to open inside the agent application when you distribute the call. For this video, we will specify a page in a demo CRM. Next, we'll set up the hold music and announcements. Start by activating the announcements. The plus sign allows you to add an action which can either be playing a music on hold file, playing a sound file for an announcement, playing the current average wait time, or playing the position of the call in the queue. Let's start by playing some music for 15 seconds. We select Music on Hold, the name of the sound file, and we set the duration to 15. Then we want to play a message to invite the caller to visit our website. This is an announcement. We select Play Sound File, then the file to play. Resume playing music for another 15 seconds. Identical to the action in step 1. Then play the average wait time followed by a message to inform the caller of the virtual hold option. The average wait time and the position in the queue actions use audio files that are already pre-recorded. The last action is another play sound file to offer the virtual hold. The sequence of actions can be of any length and can repeat in a loop. Our sequence will repeat from step 1. Next, if you wish, you can use the announce call to play a pre-recorded message to the agent prior to connecting the caller. It could be useful in some situations where you need to announce the purpose of the call or some information about the caller. You can also push any variable or information collected during the call, such as an account number, to the agent, and it will get displayed on the agent application. Next, you can decide whether you want the agent's phone to answer the calls automatically, which means that the agent will hear a short beep tone and get connected, or the call will get offered to the agent who has the choice of accepting or rejecting it. This is what we call a non-forced call, where the agent is not forced to take the call. The timeout parameter indicates how long will the system wait for the agent to accept or reject the call. If the agent rejects the call, or if the timeout expires, then it will get offered to the next available agent. And finally, you can specify what keys, if pressed, will make the call exit the queue. In our case, for longer waits, we will give callers the choice to leave the queue without disconnecting. By pressing 2, they can opt for a virtual hold, and we'll call them back when an agent is free. We inform callers that they can press 2 for virtual hold by using the announcements. Time to save this pickup box. As you can see, there are 2 exits from this box: exit 2 for virtual hold, and timeout when the call did not get distributed to an agent within the allowed delay specified for the queue. This is considered to be an abandoned call on this queue. If a call times out, you can continue with other actions in the routing script. What we will do is put the call in another queue. Before moving the call to another queue, we want to increase its priority so the caller does not end up at the end of the second queue after a long wait in the first queue. To increase, even decrease, a call's priority, you must use the priority increment box. It allows you to add a positive or negative value to the original priority, therefore increasing it or decreasing it. Earlier we had created 2 queues, a first queue specific to the skill technical support, and a second queue for the agent group. The reason behind this is the following: all the agents are part of the global agent group, but only some of them could have the technical support skill. For a caller in need of technical support, we wait for an agent with the required skill for a certain time. When this time passes and the pickup box exits with timeout, instead of failing to service the caller resulting in bad customer experience, we want to try to connect with another agent even if that agent does not have the skill. The queue for the agent group gives us access to a larger pool of agents. Let's create the pickup box for the agent group queue and place it right after the priority increment box. Most of its settings are similar to the ones in the first pickup box. Let's save this box and connect it. There is one more option in the main menu to cover. While in the main menu, if the caller presses star to repeat the menu, we want to be able to limit the number of such loops. We use a counter box that creates a counter and increments it each time the call flow executes the box. If the counter exceeds a certain number, let's say 5, we hang up the call. If not, reconnect to the main menu box. This will keep callers from continuously pressing the star key, whether inadvertently or simply to keep a line busy. Let's add a condition box to test the value of the counter. If the counter exceeds 5, then we will politely say goodbye, and we hang up the call. Otherwise, if its value is less than 5, then we repeat the main menu. Now let's open a virtual hold box. In this box you must specify the phone number at which to call back, the caller ID to display for the call, the trunk over which to place the call. Then you must decide how many times and how often to call back if there is a busy or no answer. This is a simple way of doing the virtual on hold. In a real IVR you must always confirm the phone number with the caller, who can choose to get called back at a number other than the one he called from. In such case you must use a get input box and ask him to enter the new number. That you must repeat the number to him using playback and ask for confirmation. We will simply call back at the number he called from, which is stored in the any variable. Connect the virtual hold box and add one last hang-up box if the last queue times out. Let's make sure we save our routing script. And there you have it. Our IVR is now set. An efficient IVR system routing calls to the right agents based on their skills. It ensures happy customers and a streamlined operation. But before going live, we test. Call in, navigate the menu, test the error messages, wait in the queue, try the virtual hold, and fine-tune it. Let's give it a try. We will make a few test calls to the IVR. Let's make a first call to test the business hours. We had to wait until the time is past 7 p.m. to make this call to make sure we are calling outside of business hours.
Thank you for calling Aheeva Technology.
Gracias por llamar a Aheeva Technology.
For service
We
in
hear the
English,
greeting,
please press
then the
1.
language
Para
menu,
servicio
then
en
we
español,
select
por
English.
favor presione 2.
Our offices are presently closed. Please call again between 9 a.m. and 5 p.m. Eastern Time. Goodbye.
Let's make a second call during which we test the invalid entry and the timeout on the main menu. Then we select the account balance option. We will press the 4 to get an invalid entry.
Thank you for calling Aheeva Technology.
Gracias por llamar a Aheeva Technology.
For service in English, please press 1.
Para servicio en español, por favor presione 2.
For sales, press 1. For your account balance, press 2. For technical support, press 3 or star to repeat this menu. This is an invalid selection. For sales, press 1. For your account balance, press 2. For technical support, press 3 or star to repeat this menu. We're sorry, but we did not receive your response. For sales, press 1. For your account balance, press 2. For technical support, press 3 or star to repeat this menu.
Your account balance is $18,687.
Let's try the web service in Spanish now.
Thank you for calling Aheeva Technology.
Gracias por llamar a Aheeva Technology.
For service in English, please press 1.
Para servicio en español, por favor presione 2. Para ventas presione 1, para conocer el saldo de su cuenta presione 2, para soporte técnico presione 3. El saldo de su cuenta es $70,070.
Our last call. We will go through the menus and get our call in the queue where we will hear the music on hold and announcements, and then connect to an agent. But first, we need an agent logged in to take our call. From a browser, we will log in the agent that we configured. When the agent logs in, his status becomes not ready. This agent is connected but will not take any calls. Let's try making a call while the agent is not ready.
Thank you for calling Aheeva Technology.
Gracias por llamar a Aheeva Technology.
For service in English, please press 1.
Para servicio en español.
We can hear the prompts, and once in the queue we hear the hold music and the
For
announcements.
technical support, press 3 or star to repeat this menu.
You can visit our website at the www.aheeva.com for more information on how the Aheeva Cloud Contact Center Solution can help your business thrive.
The estimated hold time is currently 1 minute.
At any time, you can press 2 and then hang up. You will not lose your place in line, and we will call you back as soon as your turn comes.
While the call is waiting in the queue, we will make the agent ready. As soon as the agent changes state, the call gets distributed and the CRM opens in the agent application. In this video, we covered the most important and common functionalities that the Aheeva Inbound offers. We showed the most important steps when starting from a blank page. Aheeva Inbound isn't just about basic IVR. Its prowess extends much further. Explore and dive deep into logical conditions, modifying call priority on the go, accessing real-time stats, integrating with web services, sending SMS, and so much more. A universe of features awaits exploration. Are you ready to take your contact center to the next level? Contact us today to schedule a demo and see how the Aheeva Cloud Contact Center Solution can transform your business.